are going to discuss the question from signals and systems given in GATE 2000. Here given that a system with an input x of t and output y of t is described by the relation y of t equals to t into x of t, then t into x of t, then this system is, this is the given question. Then we need to find whether it is linear, time invariant or not. That we need to choose the options out of these four. So coming to the solution, given that the system is represented by y of t equals to t into x of t. Coming to the linearity first, coming to the linearity concept, coming to the linearity. So here linearity is nothing but, let us consider a system y of t and the output is represented as transformations on x of t. Then we need to choose two signals. That linearity is nothing but has to satisfy the superposition and homogeneity principle, nothing but taking that y1 of t equals to, that is the transformations on the signal x1 of t, and y2 of t equals to, that is the transformations on the signal x2 of t. Then the transformations on a1 x1 of t plus a2 x2 of t must be equals to a1 y1 of t plus a2 y2 of t. This has to satisfy. When this is satisfied, we can say that the system is linear, otherwise non-linear. So we need to check this condition now. So in order to check this condition, let us consider the given system y of t equals to t into x of t. First I am going for finding the y1 of t here, nothing but that is t into x1 of t, and y2 of t equals to, that is t into x2 of t. Now I am going to find this expression, that is the, I am going to find the right hand side term RHS, that is a1 y1 of t plus a2 y2 of t, that is equals to, this is a1 t x1 of t plus a2 t x2 of t. So this is the RHS side. Coming to the left hand side, coming to the LHS side, this is the transformations on a1 x1 of t plus a2 x2 of t. So this is obtained by from the expression. So here you can observe that it is given that the y of t is nothing but, that is the transformations on x of t. Using this expression, this is y of t equals to t into x of t. Now the input is changed as a1 x1 of t plus a2 x2 of t. Then here we will get in place of x of t, that input we need to substitute. Then we will get that we'll get this as t into a1 x1 of t plus a2 x2 of t. This is a1 t into x1 of t plus a2 t into x2 of t. Now by observing the LHS and RHS sides, we can say that both are identical. So LHS equals to RHS, then we can say the system is linear. Coming to the time invariant property, coming to checking the time invariance, here checking the time invariant. That is, in order to check the time invariant, let us consider the system with output y of t is the transformations on the input x of t. Then in order to check the condition of time invariant, nothing but if the system characteristics does not vary with respect to the time, then we can say the system is time invariant. Otherwise we can call it as time variant. So in order to check that, first we'll consider the shifted input signal x of t minus t naught. For that we'll find the output represented with y of t comma t naught, that is equals to the transformations on x of t minus t naught, and we'll introduce the same amount of shift in the output, that is y of t minus t naught is equals to, that is the transformations on x of t only, but we need to replace the t with t minus t naught. That we need to check. When y of t comma t naught is equals to y of t minus t naught, then the system is time invariant, otherwise time variant. Now we will check this condition. So coming to the given signal, given system, that is y of t equals to t into x of t. For the shifted input signal, the output is y of t comma t naught, that is equals to t into x of t minus t naught. And for the shift taken in the output, that is y of t minus t naught, that is equals to, we need to replace the t with t minus t naught. Then this is t minus t naught into x of t minus t naught. So we can observe that these two are not equal, then the system is time variant. Always we can simply remember that whenever the signal x of t, whenever the signal x of t is multiplied with time, then the system is always time variant only. So now we will check the options now. So out of the given options, the system is linear and time invariant, linear and time varying. So this is the answer, that is the second option, B. Option B is the correct answer.